This is a demonstration of how you can use the Vault Secrets operator to retrieve a Terraform Cloud API token dynamically generated from Vault and write it to a Kubernetes secret. Terraform Cloud Operator can then read the Terraform Cloud team token from the Kubernetes secret and use it to create workspaces and start Terraform runs. This is a pattern that applies more generally to any secret that you have in Vault that needs to be written to a Kubernetes secret. Many Kubernetes resources and workloads do not support a file-based approach to reading a secret. Instead, they expect a Kubernetes secret to be in place to reference in order to run successfully. One such example of a resource that does this is the Terraform Cloud Operator. The Terraform Cloud Operator creates infrastructure resources using a native Kubernetes interface. So if you want to provision a module in Terraform, you can use Terraform Cloud to do it, and you can start a run using the Terraform Cloud Operator. Of course, this means the operator needs access to the Terraform Cloud API, so we need to store an API token in a Kubernetes secret. The specific example that I'll use today is a payments application that needs access to a database. It's not quite so simple to set up a database though. This database needs to be registered into Boundary for access for me to load data. It needs to be added to Consul for service registration, and it also needs to have the database secrets engine configured in Vault so I can create usernames and passwords on demand. All of these dependencies are captured in a Terraform module, which I'll be able to run from the Terraform Cloud Operator. This means that I can deploy these resources first before deploying my application. To get started, I'll deploy the Vault Helm chart. The Vault Helm chart I'm using to deploy a service account as well as additional cluster role bindings. You can do this separately, although I am using it because it is a little bit easier to deploy all of these dependencies at once. I am using HCP Vault as an external cluster, so I do want to configure a default Vault connection to the HCP cluster that I have available. This is something that I've done as part of the Vault Secrets operator in the initial deployment. I also deployed the Terraform Cloud Operator in its own namespace. The Terraform Cloud Operator will monitor for module and workspace custom resources. Next, I need to set up the Terraform Cloud Secrets engine in Vault. I've already enabled it at the Terraform mount point. This secrets engine allows you to create Terraform Cloud user, team, and organization tokens. Each of these tokens has a different scope and access to Terraform Cloud, so you'll have to determine which one is most relevant to your use case. In my case, I want to allow a team to create workspaces within a project. I don't want them to create workspaces across the entire organization though. So I create a role with the team ID for payments app. This is something I've pre-created in Terraform Cloud, and I'll take that ID and apply it to the role configuration. Do note that team and organization tokens do not have leases because Terraform Cloud can only create them one at a time. User tokens do have leases. Next, I will create some custom resources that allow Vault Secrets operator to retrieve the secret from Vault and add them to a Kubernetes secret. So this one is going to be configured for the Terraform Cloud token specifically. I'll create a service account to authenticate to Vault. The service account is something that I'll specify as part of the Kubernetes auth method. Again, I've already configured this, but the Kubernetes auth method is going to use the service account to authenticate to Vault and retrieve the Terraform Cloud token. I'll also create a Vault Dynamic Secret custom resource. The Vault Dynamic Secret custom resource references the creds path in order to retrieve a set of dynamic credentials. In this case, I'm going to retrieve the Terraform Cloud team token that I've linked to the payments app team and add that to a Kubernetes secret called Terraform Cloud team token. Finally, I'll deploy all of the custom resources and the application deployment manifests that I need in order for this application to run. I'm using Argo CD to handle all of the sequencing, so it is going to deploy the custom resources associated with the Vault Secrets operator first. So that would be Vault Auth and the Vault Dynamic Secret resources. Those are going to come first. Let's check if the secret has been created in Kubernetes. Once these custom resources have been applied, Vault Secrets operator should read the secret from Vault and write them to a Kubernetes secret. You'll notice the Kubernetes secret Terraform Cloud team token does exist in my Kubernetes cluster. This means that Any resource can use this Kubernetes secret. If I want to rotate this, I can go to Vault, rotate the role, and the operator will resynchronize the secret. Next, I'll create some custom resources related to the Terraform Cloud Operator. The first is a workspace resource. The workspace resource is going to create a Terraform Cloud workspace and does require the Terraform Cloud team token in order to create it properly using the Terraform Cloud API. So I'm going to reference it here. I also get to name the workspace and pass in additional Terraform variables and attributes. I'm using the same pattern actually to retrieve a secret from a Kubernetes secret and pass it into a workspace variable in Terraform Cloud. So the same pattern applies to any custom resource that uses a Kubernetes secret. I also create a custom resource for a Terraform module. The custom resource is going to start a Terraform run in Terraform Cloud. It is also going to require the use of the Terraform Cloud team token, and it will need the source of the module as well as the version you want to run. I define a set of module variables, and this will start a run in Terraform Cloud for me in the workspace that I've defined as well. Once I've applied these custom resources, Terraform Cloud will start a run. The Terraform Cloud Operator kicks it off, and you'll be able to review the status in Kubernetes as well as Terraform Cloud. Once the Terraform Cloud Operator has finished and Terraform Cloud has also finished, you'll be able to use the resources that it's created. So in my example, I will be able to access the database and I'll be able to use the Vault Secrets engine to create some new credentials. I've set this up actually so Boundary will allow me to log into the database and load some data. You'll notice that Terraform has created a target for me to use. Argo CD, which is deploying the remainder of the resources, has resynchronized the other dependencies that come after the database creation. So you'll notice that it's tried to create the application a few times and is now successfully running it. So with this workflow, I was able to deploy a database and all of its requirements and dependencies and deploy the application with a single command. And if there was an error that happened, then Argo CD or my GitOps framework is able to handle reconciliation and retry to ensure that it is all going to come up properly. The important thing is that if you have secrets managed in Vault, you can still manage and track their usage using Vault. You can use the Vault Secrets operator to retrieve those secrets and synchronize them to a Kubernetes secret so that any Kubernetes custom resource or workload can reference that Kubernetes secret. It reduces the overall effort to refactor an application to use Vault, and you also have the ability to leverage any other custom resources that you might need in order for your application or infrastructure to deploy successfully.